Hi class, because we didn't get a chance to go over any of the Cohen and Henle materials that you read for last week, that you read over last weekend, and that you now have an assignment about for this week, I wanted to go over a few of those problems with you in this screencast. So the first section of problems is about the derivative. And remember, as we talked about in class, the derivative is the instantaneous rate of change. So some of the problems in this section have to do with a function, and some have to do with the derivative. If you look at problem number 1a is the statement, my net worth, which we'll call the function w, right now at time t equals 0 is $55,000. So you want to think, how can I translate that into mathematics? Here's what works for 1a. W of right now, which they are saying is t equals 0, w of 0 is equal to $55,000. That would be the mathematical statement corresponding to number 1. I know it's the function that they're talking about because they've told me it's the function. It's the function net worth. And I know what time I should be putting in. I know I should be putting in time t equals 0 because they told that to me too. And they told me what w of 0 was. 1b, on the other hand, says, thanks to some good investments, my net worth is growing. When you see that something's growing or decreasing, or it says something about change, that's your tip that you're talking about the derivative, because the derivative is the rate of change. So if my net worth is growing right now, that's telling me something about w prime. And what do I put in the parentheses? Well, it says the time. It says right now, and they already told me right now was t equals 0. So this must be telling me w prime of 0. And it's growing at a rate of $6,000 per year. So my answer here would be 6,000 per year. Or you could just write 6,000. Note the units of w prime, the derivative. The units are dollars per year. Compare that to the units of w. The units of w are dollars. I could add my dollar sign up there. Let's look at number 2 now. Number 2 says the population of Malawi, we'll call that population P, so that's telling me what my function name is, was 5.04 million in 1974. So that's telling me that this function P of 1974, I'll assume the year is going to be the input there, is equal to 5.04 million people in this case. So this is giving me some information about the function, and that's 2a. Let's see if 2b tells me anything about the derivative. Here it says the population of Malawi was increasing. So there's my tip that I'm talking about P prime by 110,000 per year in 1974. So now what's the time that I put in here? It's still 1974. And it tells me my amount, my P prime of 1974, my derivative or my rate of change in 1974 was 110,000 per year. So that would be 2b. So watch for when you're being given the function, when you're being given something about the value of the function, and when you're being given information about how the function is growing or shrinking or changing. So that's some information about how you do the first section of problems. And remember, you're doing the odd problems there. I did 1 and 2, but you can just do the odd problems. The next section starts to talk about integrals. And integrals are a little bit trickier and a little bit different. Integrals tell you something about total change. So let's think about number 1. In number 1, Dorothy is petitioning to get a proposal on the ballot, and we're going to let S of D be the number of people who've signed the petition as of the beginning of the D-th day of petition. So S of 0 should be equal to 0 because as of the beginning of the day, she wouldn't have gotten any signatures. And we'll let D equal 0 be the first day of the week. So it says during the first week, she got 412 signatures. That's telling me something about a range of time, right? Because remember, S of D is at each day. So if I'm talking about totals over ranges, I'm talking about integrals. So the integral is written as a really long, skinny S because it's the sum over what happened for all days of the first week. And during the first week, my days is going to go, I'll start at day 0, the first day of the week, and I'll go up through the 7 days of the week, or maybe we should stop at 6. So let's say we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. That'll be 0, 1, 2, 3, 4, 5, 6. I think this should actually, for the first week, go 0 to 6 if we're going to start at 0. Our day is going to end, our week is going to end on day 6. So I'm going over that 0, the 0 here, and the 6 here. Tell me that I'm going from day 0 to day 6, or I'm stretching through a whole week. And I just put S prime in here to tell me that I'm looking at this function S of D. And why do I put S prime in there and not S of D? Because I'm saying I'm going to sum up over all of the change. So here I'm looking at that S prime is equal to the rate of change of S of D. And that's just what you put on the inside of the integral. And on the other side, we put how many signatures she got over that whole week. So what this sentence now says is that from day 0 to day 6, Dorothy got 412 signatures, right? Which is exactly what we want it to say. We want it to say during the first week. Now, this was 1A. Let's look at 1B. That talks about during the second week, how many signatures she got. So we would again want an integral because we're looking over a whole span of time. What we write here is just S prime, and just think of that as notation for the moment. We're not going to have a better context for that for some time. But what I can change is what I would put in here and here. These are going to be, I want to know what day I'm going from and what day I'm going to. So now I'll pick up on day 7, and then I want to go Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So I want to go from 7, 8, 9, 10, 11, 12, 13. I want to go from 7 to 13 during my second week of collecting signatures. And during that second week, as it turns out, she got 656 signatures. So that's what the symbols around the integral are saying. And I'll tell you 2 things about the integral before we do number 2, is that number 1, it feels more complicated than the derivative. I think that you can already see that. And the second thing I want to say is we're going to be focusing mainly on derivatives during this semester. So I'm kind of thinking of the integrals right now are sort of like the sprinkles on top of the ice cream. The ice cream's the most important. That stuff about the derivatives is most important. And this integrals, I want to give you sort of a flavor of what's to come and some more language that you can use. So let's see what we can do about number 2. Number 2 talks about Nantucket Island, which is shrinking. And we're going to let A of t be the area in acres of the island in any year t. So first of all, what does A tell us? Presumably something about the area. So in 1997, so that's going to be our time t, Nantucket was losing area at a rate of 6 acres per year. So they're telling us about losing area. That's that little bling word that says, we're looking at a rate of change. That means we're actually looking at a derivative. So 2A is a statement about the derivative. It's going to be the derivative of the function A, the area function. They told us at 1997 or in 1997, so they tell us what goes in here, and then they tell us what A prime of 1997 is. It's losing area at a rate of 6 acres per year. So we've got 6 acres per year. And if I just write this, it would look like I was going up by 6 acres per year, right? So I'm going down by 6 acres per year. So this A prime should be negative. The rate of change is decreasing. So that negative tells me that I'm decreasing every year. So as it turns out, 2A is a statement about the derivative, and we can tell because of this statement about losing area. It tells us that it's a statement about the derivative. Now look at 2B. 2B gives us a range. Anytime you are given a range of input values, that's kind of a good tip that you may be talking about integration. So here we're going from 1997 up to 2003. And it's telling us the total that we lost, not what we lost each year, but what we lost during that entire range. So that says use this great big S to sum up over all of the changes. So that's why I'm going to put A prime in here, right? Because you can think of this S piece as saying sum up, right? That's going to say add up over these years. And the A prime says add up all the changes that happen. And when we do that, they tell us what the answer is. They tell us we lost 30 acres. So again, we want to make it negative. And that's the grand total of what we lost. So hopefully this can help you to get started on those problems, the problems from the Cohen and Henle packet that you got last week and you're now working on this week. Do as many as you can, figure out what you can, talk to other people about it, and we'll talk about this at the beginning of class. And I will see you on Monday.